To the land of the lost. To the land of the
G'day everyone, it's Max, and welcome to my Minecraft Land of the Lost tutorials. Over time, I've been playing my LOTL series and my Iron Man series. I've been asked by my viewers on how I do certain things, or where ideas come from, or even just some general questions, and I'm hoping that these tutorials are for them. So first, a big thanks to my viewers and my subbers for these tutorials are a dedication to them. Credits for today's innovators and inventors of Ethos, DocM77, PearSquirrel, Static, MinecraftAddict, Roboticaust, and many of their viewers who have provided many great instructions to Minecraft, along with Necramar, who is I consider probably one of the fathers of early alpha redstone tutorials and has provided the map which I will be using in my tutorials, and to Copern, who provided a great invention of double swing boosters, which before powered rails, that was just a great invention, and I have credits and props to him. These tutorials I do will never be as intense or as great as those mentioned, but I try to design these tutorials around the true beginner who are just starting out in Minecraft, and by laying out circuits and steps in a much larger format than what you'll see in many tutorials. Of course, I'm very impressed by how some of these players can actually make circuits work in just like 1 or 2 blocks. That's definitely not me, but my circuits will be laid out and function so as even new players just jumping into the game and want to design some really cool things will be able to do so, and I can explain it out in a very efficient manner and they can be easily followed. Finally, be sure to check the video notes for all the links to the names mentioned earlier, along with information to different mods, wikis, and forum posts which I may have used during the video in the tutorial. And finally, I want to thank everyone who's been watching all of my series, and including these tutorials, and I hope you find them informative and help you a lot in your worlds. With that, let's have a look to see what I'm doing today. Okay, today's tutorial is based on simple redstone basics, and so this tutorial is just gonna handle through some of the basics on redstone, what it is, how it works, and a few of the different things we can do with redstone in general. Redstone really added another element to Minecraft. I mean, it just it took from the ability to just build things and then added like wiring to it, and allowed a whole new dimension into building neat little electronics and different things that over time people have really taken off with redstone. Redstone itself is really just a powder, which is a mined powder, which is found in the lower parts of cave systems and mines, above diamond, but definitely more lower than iron. And when you mine redstone, of course it looks something like that, and you pick it up, and when you put it down it does this. And basically redstone is just it's an electrical current wire, and the nice part about redstone is that now it brought that element into the game where you know, you can make really cool things like you know, automated door openers and switch tracks, and for the real far out examples like 20 pixel TVs, and of course with pistons it allowed for like huge piston waves and just so many nifty things. I am not nearly that advanced in redstone. In fact, some of the stuff that you see me do in my tutorials will actually look a little drawn out, and that's because unlike some of the great redstoners out there, such as PearSquirrel and MinecraftAddict, My redstone just isn't that advanced, but my redstone basics is good enough that I'm still able to build some really nifty things, which of course, like my tutorial that you'll see coming up on the track switch, three-way track switch, and my 4-port or even more hub station. Even with just simple basic redstone knowledge, you can really build some nifty stuff. So let's go with that. So of course, redstone, as I mentioned, is basically an electrical current creator and allows you to build machines with power. The first thing you need is redstone itself, as I mentioned. Getting that through mining and in lower parts of caves, you get this wonderful redstone powder, and then you can run a wire, and that's what we have here. This is an unpowered wire at the moment, and so then we need to talk about how can we send power through a wire, and there's basically 3 methods to that. The first is this, and this is a redstone torch, and this redstone torch, when you make them, it's a piece of redstone and a stick, and when you put them together, it gives you a powered redstone stick or redstone torch. And you can take these redstone torches, put them on the end of a wire, and presto magico, you've got power, and you are now supplying power to this wire. Now power goes down redstone for 15 blocks, and as you can see, as the farther you get away from that torch, the redstone's starting to get pretty dim, so it gets darker and darker, and then after block 15 there is no power. It's a dead wire. So we'll talk shortly about how to rectify that, but that is the first way to provide power to redstone line, is by sticking a powered torch on the line. Now, because of neat nifty inventions, the next thing we'll talk about how to get power to a wire is a button, and you just need 2 pieces of smooth stone for a button. And the nice part about buttons is that it's like it's an on-off type circuit. So when you push the button, it's going to power this wire over here, and that will light up. So we'll push the button, it lights up, and then when the button pops out, the wire turns off. And so that button lasts about 1 second long. And sure enough, that's how that works there. So that is the second way we can provide power to a wire. It's not a continuous power. It's only for when the button is pushed in. Now, that makes things very convenient in certain episodes, and at other times you kind of wish that the button would last longer. So like when you push a button, you'd think, oh, I wish that would just kind of stay on until I want it to turn off. And we're actually going to talk about how to fix that too. But that is the second way. The third way is through a switch, and this works just like a lighthouse switch. So it's currently up in the off state, and when you click the switch, it is currently in the on state and stays on until the switch turns back. So basically the switch is kind of like a controllable redstone torch, where when you put the switch down, it's like the redstone torch is there and it's on. But the nice part is that you don't have to keep breaking off the redstone torch every time you want to turn the power off. You can just flip the switch and the power is off. So that is the 3 methods we have into dealing with redstone. We can turn redstone on with a torch, we can turn it on with a button, and we can turn it on with this switch. Now, let's go back to our redstone wire here for a second. So, as mentioned, redstone power will travel through 15 blocks before it gets too weak and basically dies out. Now, we can extend the range of wire by the use of what is called a repeater. Now, here on my left, which I will now turn to, is a good old-fashioned repeater. So, before the days of nice repeaters from Notch, we used to have to make repeaters like this. So basically, as you can see here, it's 2 blocks. We have the redstone torch on this one with a wire in front of it, and then we have a second torch on the front of this block. And that's because the way this works is when a redstone torch receives power, it burns out. So this redstone torch here is is on and is giving power, and the power is coming across this one piece of wire, and when it hit this redstone torch here, it short the torch out, so it basically went poof and turned itself off. So the wire on this side of the block is off, the wire on this side of the block is off, and what this button is going to do now is when we push the button, the wire is going to turn on, and when any redstone torch receives power, it burns out. So this torch would go off, but in turn, because this torch goes off, this torch can then come back on because this wire here won't have any power in it anymore. And then the wire here can then pick up where it left off. So this is an old-fashioned repeater which we could use to extend wire more than 15 blocks. So I'm going to try and stand over here a little bit, and then I'm going to extend my reach to like 10, so I can push this button way over here, and you'll see that both sides of that wire are actually lighting up. That torch is going out, but the front torch on that is turning on every time it does, and it provides the wire out. Now, the new type of course repeater system is the crafted repeater, and we'll just put one of those down, and it's nice. You know, it's compact, one block, and has additional properties. So in this particular case, you notice I put the repeater in, and now this wire has all kinds of power again to go for 15 blocks from the end of that repeater. So really, I could put this repeater all the way out here, and presto, then I could go 15 more blocks and I'm set to go. And as you can see, the powers are all kinds of power. Now, just for viewing purposes, I'm going to actually put that repeater back here, because that's the first thing. Even though a wire can travel 15 blocks with power, you won't necessarily want it to all the time before putting in a repeater. And the first reason is because the new style of repeaters, you can put a delay on them. Now, by default, when power comes into the back of repeaters, it just immediately shoots out the front of the repeater and keeps going. But we can right-click on this repeater, and as you can see, that torch in the middle there now kind of looks like that back one here, right? We're actually stretching out the time that it takes for the power to get from the back end to the front end and then come out. In fact, for every 2 repeaters that are fully stretched out, you've basically added about a half a second to time. So if you put down 8 repeaters, or my mistake, for every 2 repeaters fully stretched out, you add almost a second to time. So if you put 8 repeaters down and you stretch them all out, you've basically added 4 seconds that it's going to take for this wire to get from the back of these to get out the front of that. And so what I'll do is I'll take this torch off for a second, and when I put the torch back on, the power is going to hit the back of that repeater almost immediately, but then it's not going to get out the front of it, of this set of repeaters, for about 4 seconds. So I hit the power, and presto, and then you notice as soon as it came out the other side, it was off like a shot. Boom, it was like a bullet. So of course, that is the first thing about a repeater, these nice little new repeaters that you can craft with a couple of redstone torches, a piece of redstone, and 3 blocks. And the first thing is that we can delay these. This will come in very handy later on to fix our button issue, which of course, as I mentioned earlier, we would like this button sometimes to stay on for like 10 seconds, maybe 15 seconds. Well, that's how we're going to fix it. We're going to put in a set of delayed repeaters somehow, and we're going to have a look at that in a bit. Now, the second thing that repeaters do, and I'm just going to take these out for a second just to demonstrate this. The second thing that a repeater does is that it only allows power to go in one direction. So if for some reason we have power here at this torch and we put a torch on the back of this, power is going to go through the back half of this repeater and out the front. So we do that, and sure enough, the power comes out the other side and keeps going. But when I put that repeater down, I was pointed in this direction, and I did that on specifically because if power now comes in on this direction, it cannot get back through a repeater. So I'll put a torch here, and you notice the power cannot come back through this repeater and into this piece of wire here. Now that's important because sometimes when you are using repeaters for delays or for other tricks that we're going to have a look at, the power that will be on this side, you do not want to interfere with something that's going on over here. This gets really important when you build bigger projects such as like the 4-port hub, because in building bigger projects, you will have the need of power in certain locations and not in other locations. And repeaters are great at stopping power from backfeeding on itself. So that is the second thing about repeaters, is that repeaters here are really good at stopping power from being able to backflow down a line when you don't want it to. And we'll just get rid of that rain because that just interrupts things. Now, just once again, just to show off the good old-fashioned old repeater, of course, when we push the button, the repeater does its job. It then turns on this torch and allows the wire to keep going through. And, of course, when you put a bunch of these in a row together, it would do the same thing as this one. It would, in fact, eventually become a delayed set of repeaters. But, of course, these ones make it very handy. Never forget about this repeater here, though. I've heard at times that these repeaters are a little flaky when it comes to logging out and logging back in. I'm not quite sure why. I've never really had any problem with them, but then again, I've never worked on big mega projects with them. And I hear that the old-fashioned repeaters, of course, never fail. So it's because of, I mean, they're made up of simplicity parts. So just one of those kinds of things. With repeaters now covered, the last and final thing to talk about is called inverters. Now I'm just going to take this out of here for a second and put this redstone wire in here. Now in this particular case, I will take these torches out so there's no power in the wire, and put a torch on the end here, and then when I put one on the end here, okay, you'll see that they're both lighting up. So if now I take a block and I put a torch on top of it, notice the torch is burnt out. Now sometimes you will actually want this torch to be on. So the problem is, of course, is that this torch is feeding this line, and this line is feeding into the block, burning the torch out. But sometimes when you turn a wire on, you will want this torch to be on. So what we do is we will invert the signal. So I will take that out of there for a second, and right here what we do is we'll take two of these out and we'll put in a block with a torch in front only. So kind of like our setup with the repeater with the two blocks and a torch. This one's missing the back block, and basically what this is going to do is, you notice now that we haven't added any power here yet, but because we haven't added power here, this torch is allowed to turn on, which is forcing this torch off. So when I actually do put a torch down here, that torch at the end should also come back on, and it does. And so sometimes you will actually want something to come on and actually have something at the end come on, and if that's not working for you, you may have to invert the line, because the line sometimes you will need to actually switch the current from an on state to an off state to get the result that you want at the end. And in this case, I wanted that torch to light up, but only light up if I provide it with power in the first place. And so to do that, I actually had to do a little quick swapping here by burning the torch out and then turning this wire off, which allowed this to turn back on. So now I'm going to just clean that up a little bit, and we'll put our wire back down here, and now we'll move on to the next thing. Now, from our 3 ways of power and redstone repeaters to actually talking about different types of input. Now, the first type of input besides a straight flow through of input over here by just flicking the switch or hitting a button, is what is called the OR gate, or the OR decision maker. Now, for example, we have a door out there, and if we push the button or we push the switch, we want that door to open. So if I push the button, the door opens, and if I flip the switch, the door opens. And this is an OR gate. It's the simplest of logic gates that you can have, and basically it's the two pieces of wire come into a central piece and then take off and go to whatever you're trying to control. And of course the nice part is that it doesn't matter which one of these I use, the power is being held on all the time in this particular case and then going down the one line. The next one is a little more complicated, but it's very similar to the OR gate, and this is an AND gate. So in this particular case, for this door to open, I need to push the button and I need to turn on the switch. So if I just use the button, nothing happens. And if I just use the switch, nothing happens. But if I use the switch and the button, the door works. Now the reason that is because, as you can tell the slight difference from the OR gate, on top of the AND gate there's two torches, and as I mentioned earlier, when a torch gets power, it burns out and turns itself off. So on the front of this block we have one burned out torch, because on top of here we have two powered torches coming together with a piece of wire, and then this torch is attached to this piece of wire, and because it's attached, it's burned out. And of course, to make this torch come on, we need to burn out both of these torches so there's no power in this wire. So by turning on this switch, it burns out this torch, and then by pushing this button, it's gonna burn out this torch, then this wire will turn off, allowing this torch to turn on and open the door. And that is why this is called an AND gate, because you have to have this and this to make this successful. And of course you'll use AND gates for when you need two decisions to make up a single result. So like for example, I'm sitting in my cart and I'm at the switch station, so I push the button and it goes. Okay, so sometimes you'll use OR gates where power from one place or the other place will make things happen, and sometimes you'll have AND gates where you need power from one place and a second place before you want something to happen. Now the third and final type of gate I'll talk about is a little bit more sophisticated, but not really when you look at it basically. It's called the RS NOR latch. I like to call it the memory cell, and that's because it's a 3x3 block of 2 blocks of redstone torches, and basically what a memory cell does is it just remembers constantly power on one side of it. So one side of it's always burned out and turned off, and the other side always has power and turned on. So what's happening here is this torch is on, which is powering this wire into this block, and that powered wire is burning this torch out. Now this torch, because it's burned out, is not powering this wire, which is leaving this torch turned on. The nice part about memory blocks though is that you can swap them with a power source. So if I put a power source here, this is going to go in reverse, because now this torch will burn out, allowing this torch to come on, like so. And if I take that torch out, it will stay on because it's now in that continuous loop state where this torch is always powering this one, keeping it burned out. And this torch is always burned out, so this one can always stay on. Now if I put the power torch back on this side, it returns the power, and once again it will stay there. And that is why I call it the memory block, because it remembers your push or decision of what it is you've done to one side or the other. Now this is where it solves our little button problem. So remember, our button back here, it lasts for 1 second, and I'm thinking, gee, I wish that power would last for like 5 seconds. Well, this is how we can take care of that, by using a memory block. So over here I actually have an example. So here we have a button, and it is attached to that door, and just for hoots I will actually hook up the door directly, and we'll just run the wire here for a second, and my poor mouse placement. There we go. Let's see if that actually going to work. Yeah, so there we go, right? So this is our standard door with a wire running to a button, and the button lasts for 1 second, and then as soon as the button pops out, the door closes, and you're thinking, well, I can't run all that way. I wish that door would stay open for like 5 seconds. Well, it can. So what we're going to do is we plug that into a memory block instead. So what we've done now is we've plugged our button into a memory block, and I'm going to actually just oh good, I've already taken that piece of torch out there for a second. So now what's going to happen is this button, when it gets pushed, is going to swap the memory block over to this side, and this door will continuously get power, which means it will stay open. So let's give that a shot. And presto, just like that. And that is great. So now I got plenty of time to walk up here, walk through the door, and I'm thinking, yeah, that's great. Wait a minute, the door isn't shutting now, and that's because the memory block is remembering to keep the door open, right? That's the power it's always getting. So if you remember a few minutes ago, I talked about repeaters, and the nice part about a repeater is that we can have it delayed. Now, the second thing that we would probably want to do with this door is, after I get through the door, it would be really nice if the door would shut itself, and that means we need this memory block to forget to put the power on this side and return the power back to this side, so it would burn out this torch. This is where I can take my button and add a second piece of wire to it, and so the first time I push the button, the door opens, but at the same time it will also go down this way into a set of delayed repeaters, and they will slowly work their way through, and you'll notice that these repeaters are joined into the back half of the memory block. So what happens is I push the button, and I'm just going to break this wire here for a second just so as that door will close. Oh, and actually I'm just going to have to reset the circuit over here. It's probably easier that way. We'll actually get to see this in action here. Pow, presto, like that. So in this particular case, what's going to happen here is I'm going to push the button, and that is going to turn this side of the memory circuit on, and the door will stay open. But it won't stay open forever, because at the same time power gets sent down this wire and starts into our delayed repeaters, which are going to turn this memory cell back to the way it is now and burn out that torch. So we push the button, that allowed the memory block to switch, but here comes the repeaters and they switch back. Now I have the 5-second timer, and I have a great delayed repeater system, which allows me to have a delayed door reaction. So this gives me enough time, and the door shuts behind me. So memory blocks combined with delayed repeaters are great for doing memory block items such as delayed door shutting, delayed switches, which is what we're going to be looking at in another tutorial, even working on hub stations. They come in real handy for that too. So that is the basics of my Redstone tutorial. It is not the all-inclusive, you know, there's like, you know, T flip-flop switches and all that stuff, and I'm sure all that's really great. There's also clock timers. There's lots of tutorials out there on clock timers and T flip-flops and that kind of stuff, but I don't really get into heavy redstone because I've just never really needed it, and for a lot of projects you don't really need big heavy understanding of redstone. What you need to know about is redstone itself being powered 3 different ways. You do need to know about repeaters because you've got to have a way to extend your power range past 15 wires. 2, you've got to know how to set up a delayed system, so as of course we can build memory blocks later. And 3, the other thing of course is about repeaters is that they prevent power from backfeeding through a system, which may come in handy for other bigger projects. Then of course the OR gate and the AND gate are probably the 2 big ones here, where one or the other will work just fine, and in this case over here you need one and the other before it works just fine. And finally, memory blocks. They're just handy things to have, you know, for doing delayed doors, for doing switch stations, anything that you want to be able to push a button on and then just kind of sit back and wait for it to go back to its own natural self, but you want it longer than 1 second, then a memory block combined with a delayed repeater on the back side of the block will definitely fix you up, and it's a great deal. So with that, that is my mini tutorial on basic redstone, and this is definitely going to come in handy for building the 3-way switch station, my 4-port hub station, and a couple of other tutorials on double doors and stuff like that, where it just having reverse inputs outputs is nice and easy. With that, this is Max signing out.
When I look all around, I can't believe the things I found. Now I need to find my way. I must find me living in the land of the lost. Living in the land of the lost.